All right, friends, we're going to go ahead and start with lesson 3.1, which is rational numbers and decimals. Our learning targets for today is I can convert a fraction to a decimal by dividing the numerator by the denominator. And our second I can statement for today is I know that the decimal of the rational number either terminates or repeats. What I want you to go ahead and write down is just the title now, 3.1, rational numbers and decimals. Okay, so before we get started today, we're going to have to know how to properly read numbers according to their place value. So we're going to do a mini lesson here on place value. So we have 0.2. That's one way we can read it, but there's one correct way to read it based on its place value. So if we look at the 2 here, 2 is in the 10th place. It is one place value to the right. It is one place value to the right of the decimal, and that is our 10th place. So that means we have 2 tenths. So go ahead and write this down. You have 0.2 is read as 2 tenths. And then when we take a look here at our second one, we go into the 10th place, and now we're in the 100th place. We have 33, and that goes in the hundredths. We read 0.33 as 33 hundredths. So I always like to make sure that I kind of spit a little bit when I say hundredths, because that differentiates between the hundreds place and the hundredths place. And then last example that I have here, we have the 1 in the 10th place, the 2 in the 100th place, and the 4 in the 1000th place. So we have 124 thousandths. So we can read it as 0.124 or 124 thousandths. So one thing you want to make sure that you're doing at all times, and I emphasize that, is that all fractions should be in simplest form unless stated otherwise. So about 98% of the time, you will always be asked to keep your fractions in simplest form. Now, a lot of people say, well, how do you simplify a fraction? Well, here is just a little quick way that I remember how to simplify a fraction. So let's say we have the fraction 1. Come on, pen. Let's not do 1. Let's go 5/20. Well, right now we need to find a number that goes into 5 and a number that goes into 20, but it has to be the same number. So sometimes I like to just say, whenever in doubt, start with 2. So let's say I did 5 divided by 2. Would that work? It could work, but it does not come to be a whole number. It comes out to be a decimal. If I do 5 divided by 3, well, that doesn't work either. 5 divided by 4, once again, does not work. How about 5 divided by 5? Okay, 5 divided by 5 works. That equals 1. So I can try it down here at the bottom. 20 divided by 5. Oh, hey, that works too. 20 divided by 5 is 4. So 5/20 is equivalent to 1/4. Let's say I choose another example. Let's go with 3/24. So once again, how do I know if this is in simplest form? Well, sometimes I'm just really good at my multiplication facts and I know it. But if you're not, that's what I say. Whenever in doubt, start with 2. So if I did 3 divided by 2, would that work? Once again, no, it wouldn't. It's not a whole number. All right, let's try 3. 3 divided by 3. Oh, hey, that one works. 3 divided by 3 is 1. How about if I do 3 divided by 24? Well, if I'm not sure, I can look over on a multiplication chart. I can look in the column of 3. Do I see 24? Yes, I do, right here. So it goes into it 8 times. 8 times, so I know that 24 divided by 3 is 8. So it simplifies to 1/8. Or let's do one more. Change my pen color real fast. Okay, let's try 12 over 22. Can I simplify that? Okay, well, once again, I'm thinking here in my multiplication facts, I need to see what number goes both into 12 and 22. So again, whenever in doubt, start with 2. That's what I always do. All right, let's see. Well, I'm kind of skipping ahead because I kind of know that 12 divided by 2 is 6 and 22 divided by 2 is 11. 11 is actually a prime number. And that's how I know I can't go any further. So I know that 6/11 brings me down into simplest form. So always double check. And like I said, whenever in doubt, start with 2. And if 2 doesn't work, you keep going and you keep going until you feel like you've gotten where you wanted. If you do 2 and you see, oh, maybe I could do it again, you can do that multiple times. That just means you didn't find the greatest common factor when you were simplifying. All right, I want you to go ahead and take a minute right now to write down the definition of rational number, terminating decimals, and repeating decimals. So rational numbers is a number that can be written as a ratio of two integers, a and b, where b is not 0. Remember when we talked about dividing by 0? That means you have 0 friends, and that makes us sad. They can be negative and must either terminate or repeat. So let's talk a little bit about rational numbers real quick and how they really look. So the first few letters of rational numbers spell out the word ratio. And there's 3 ways that you can write a ratio. You can write it as a over b, a colon b, or a to b. So our focus is going to be in this form. But once again, as I've said before, b cannot equal 0. B cannot equal 0 because remember what happens when we divide by 0? We have an undefined answer. And when our answer is undefined, that means we have no definition to it. There's no response. And as Siri told me before, if I have all these items and I have 0 friends to share it with, I'm a sad person because there's nobody to share with. So you need to make sure that you are not dividing by 0. We also have a terminating decimal, decimals that come to an end. So that means when you go ahead and divide them, which we'll do in a little bit, there is a final answer. The answer stops, it does not continue, so that means you are done. And then we have repeating decimals where we have 1 or more digits that repeat indefinitely. So that means we might see something like 0.33333 or 0.121212 or 0.3334, 0.3334, something like that. Okay, let's go ahead and move forward. Remember, you can always pause this video if you just need a second to catch up. All right, so the essential question we are going to answer is how do we convert a rational number to a decimal? How do we convert a rational number to a decimal? So remember, once again, the first few letters of rational number are ratio, and we are working in the form of a over b as long as b does not equal 0. All right, how do you write a fraction as a decimal? So once again, before we continue forward, always remember that this bar here, 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 here represents division. So we are going to go ahead and convert these fractions into decimals. So before we begin with that, we need to make sure that we understand that what goes in the house is on the inside, and on the outside is our denominator. So our numerator goes inside and our denominator is on the outside. So I'm going to go ahead and put 5 on the inside. But I also always like to put a little decoration in my house. I'm going to add some extra zeros just so I can successfully have something to drop down later. So there's 16 on the outside. I like to raise my decimals so I know that I'm working with my place value. Place value is key in long division. All right, let's go ahead here and get started. We have 16 going into 5. 16 cannot go into 5, so we're going to go ahead and put a 0 up there. 16 times 0 is 0, so that's where I put my answer to 16 times 0, and then I subtract. 5 minus 0 is 5, and then I go ahead and bring down my 0. So now I have 50. Well, to be honest, I don't know the multiples of 16 very well. So I'm going to go over here and look at my chart. I'm going to look here in 16. Where do I hit 50 without going over? Okay, 64 is not enough. Oh, 48 does, so it goes 1, 2, 3 times. So I'm going to do 3, and then I have 48 with a remainder of 2. Drop down my next 0. How many times is 16 going to 20? Well, that's easy. That's 1 with a remainder of 4. See why I put all that decoration in there? Drop down another 0. How many times is 16 going to 40? Well, once again, not 100% sure my facts. Oh, 48 is too big, so it's 32, so it goes in there 2 times. 16 times 2 is 32 with a remainder of 8. Oh gosh, I don't have enough in my house. 0. Drop down the, oh my gosh, I'm running out of space. 80. So I'm going to go back and look at my facts of 16. 80. Oh, I see 80 here. So it's 1, 2, 3, 4, 5. Oh my goodness. Okay. 16 times 5 is 80 with a remainder of 0. So 5/16 as a decimal is 0.3125, or if we're going to read it based on its place value, tenths, hundredths, thousands, 10,000ths. So it would be 3,125 10,000ths. Yeah, I know. I'm super extra right there on that one. Okay, so now we have to answer the question, is it terminating or repeating? Well, it looks like we got to a divisor here. We got to an answer of 0. So this is a terminating decimal. All right. Let's go ahead and try this next one over here. Same thing. 13 goes in the house. 33 goes on the outside. We'll do 13. Oh, let's try that again. 13.000 divided by 33. So again, I'm going to bring my decimal point up here, and then I'm going to go ahead and get started. 33 into 13. Well, I know that's 0. So we'll have a remainder here, 130, and then now I need to ask myself, oh, how many times does 33 go into 130? Once again, I'm not great at my multiples of 33, so I'm going to try to check this out. 130 divided by 33. So it can go into there 3 times. So it says 3.9393. I don't care about this 93 part. I just care about how many whole times. So I know that it goes in there 3. So 33 times 3 is 99. 99. So you see how I'm using a calculator as a tool now? 130 minus 99 equals 31 is the remainder. And then I bring down my next 0. So now I have 310. So again, not really good with my multiples of 33. So I'm going to use my calculator. 310 divided by 33 equals 9. Okay, so now I put my 9 here. And then 9 times 33 is 297. With a remainder of 310 minus is 13. And then look, oh, bring down a 0. Well, what do you notice here? It's at 130 again. So then it's probably going to end up being 3 again, and I keep going. So this will be a repeating decimal. So once you notice that, you don't have to keep going. So what we do is we draw the bar on top. That's called bar notation. That represents to you and your audience that 39 gets repeated over and over. So you would read this as 0.39 repeating, or you can say 39 hundredths repeating, something along those lines. All right. So right now, we're going to continue on working on these. I know I've ran out of space, so I'm just going to be a little janky here. And whoops, I'm going to go like this. Close this off, and then I'm going to go ahead and do 17 40ths. So once again, 17 goes on the inside. Add some extra decoration in my house. Not 14. 40 goes on the outside. Raise my decimal. 40 goes into 17 0 times, with a remainder there of 17. Drop down my 0. So how many times is 40 going to 170? I'll do 170 divided by 40. It goes into there 4 whole times. 40 times 4 is 160, with a remainder of 10. Bring down another 0. 40 goes into 100. 100 divided by 40 is 2 whole times. And 2 times 8 is, or 2 times 4 is 8, so that's going to be 80, with a remainder of 20. Bring down the 0 again. 200 divided by 40 is 5 wholes exactly. So that equals 200. We end up at 0. So our final answer here is 0.425. This stopped. So this is a terminating decimal. All right, let's go ahead and do one more. I know this is, like I said, kind of janky, but we'll get it done. We'll go this way. All right, and then we have 11.000 divided by 24. So you should have been writing all of this down. I know I didn't preface that when I started, I'm sorry, but please make sure you have all 4 of these examples in your notes. All right, I'm going to go ahead, raise my decimal. 24 doesn't go in 11, so it's 0. So now I have 11 here and drop down a 0. So 110 divided by 24 is 4 times. 24 times 4 is 96. So it's 14, I believe. Just going to double check because I make mistakes all the time. 14, and then bring down the 0. 140 divided by 24 is 5 whole times. 24 times 5, 120. So we got 200. 200 divided by 24 is 8. Oh my gosh, tight squeeze. 8. 24 times 8 is 192. 192. OMG, I need more space. So we have 8, and then I should drop down another 0, but I have no room. So next to the 8, we have 80 divided by 24, which is 3. OMG, 3. 24 times 8. Nope, 24 times 3. 72. Oh my gosh, they're killing me here. 72. And then it's 8 again, which would be 80 in it. Look at how far we had to go to figure out that this decimal is actually a repeating decimal. That one was rude, but long division does take a long time. Sometimes I'm kind of nerdy and I think something like this is fun after a while. All right, so go ahead and join me on page 63 of your textbook, or if you really want, you could just write these 3 down in your notes and do it from there. So you're going to go ahead and convert 4/7, 1/3, and 9/20 into a decimal. And I want you to go ahead and pause your screen here. And then when you are done, go ahead and check your answers. So now that you've kind of worked on this problem, 4/7 as a decimal is 0.571428. And what's awful about this one, it is so long, but this ends up repeating. So that is a repeating decimal. 1 divided by 3, that's another one like a half. You should have that memorized. That's 0.3 repeating. And 9/20 is a terminating decimal, 0.45. So this is repeating, this is terminating, and this is terminating as well. Oops, I lied over here. This is not terminating, this is repeating. Okay. All right, we're going to go finish up and have a question here in regards to turning a mixed number into a decimal. So it says Michael rode his bike 6 3/4 miles to the Science Museum. Right, 6 3/4 as a decimal. So 6 is our whole number. 6 is our whole number. So we know that it's going to go to the left of the decimal. So we're going to have 6 point something, 6 point something. So you have this decimal now, which is 3/4. So just like we were doing before, 3 goes on the inside, 4 goes on the outside. Raise my decimal. 4 goes into 3, 0 times. I have a remainder of 3, bring down the 0. 4 goes into 30, 7 times. 4 times 7 is 28, and remainder here. Drop down the 0. 4 goes into 20, 5 times, with a remainder of 0. So the decimal here is 0.75, but we have 6 3/4, so it's 6.75. So if this was 74, then the number in front of the decimal would be 74. That's just a quick way to do that. All right, I want you to go into your textbook on the bottom of 63. I want you to go ahead and answer these. 7 says Yvonne made 2 3/4 quarts of punch. Write 2 3/4 as a decimal. So I'll give you a hint here. It's 2 point something. If you need help, look back at the previous example, and then you need to tell me whether it's terminating or repeating. Next one says Yvonne bought a watermelon that weighed 7 1/3 pounds. Write 7 1/3 as a decimal, and then once again, write down what you have as terminating or repeating. Sorry, technical difficulties over here. This. So now that you've kind of done these, I hope that you pause so you can see how you did. So 2.75 or 2 75/100. This decimal is terminating. 7 1/3 would be 7.33, or you can use the bar notation as 7.3 repeating, and it is a repeating decimal. It is a repeating decimal. All right, so your mission right now is to work on page 64 in your textbook. You are to complete the whole page. What you do not finish is your homework tonight. Now is a perfect time to come and see me and ask any questions if anything was too confusing, or if you need a multiplication chart, or if you need to just think out loud. Please come and see me so we can work on that. Once again, if you need any questions or need any answers or need anything, please do let me know. All right, thanks so much.